Hello, my name is Andrew Gleeson. This is my 2018 DTC project Autonomous Yacht. This is a small preview of what we'll get back to later. This is my first prototype Arduino sweep using the sweep code from the Arduino package and a servo motor. A very easy to set up, basic small prototype which makes the servo turn 80 degrees and backwards and forwards. This is my second prototype Arduino Potentiometer. It's a prototype which uses a servo in conjunction with the potentiometer. It's again an example from the Arduino package, and what it does is make the servo turn to the angle of the potentiometer, so it reads the angle of the potentiometer and moves to that angle. A very useful and helpful piece of code I soon found out. This is the piece of code that went with the potentiometer sweep. Obviously, again, very simple. This is the construction of the center capsule which would go into the hull of the yacht. So this is the capsule itself with an Arduino and two servo motors. A very basic design, and I was lucky enough to be able to essentially plug and play with this part of the build. This is the plan which I made with the idea of using potentially a rangefinder, GPS, compass, two servo motors, an Arduino and or a Raspberry Pi, and obviously batteries. A very simple but hopefully effective method. This is further on in the project when I began soldering all of the parts to a breadboard to connect them all into a parallel circuit. This is me demonstrating how I've wired the compass sensor and the servo motor for steering in together so that in theory the boat will steer to a compass heading. The code itself used for this small prototype was still quite simple, and I still had yet a lot of things to do with the code, as I still had to add another servo to the circuit to allow for sheet control to control the sail. And with this I'll have to enable another axis of the sensor into the code to allow it to work efficiently. What I'm about to do here is show the pushrod action between the servo and the rudder control and what it does. Obviously I have to set some new parameters, as on one side it steers too far. Coding was obviously a large part of my project, and I had to learn a lot about the Arduino C code. Learning how to set parameters and how to write a void setup and loop were all part of this process, and helped me to write efficient code that worked. Another part of the coding process was to learn how to use sensors and servos together. As you can see on the left hand side of the picture, there are two servos there from my center console, and the wires heading downwards are going to a sensor which is compass heading and accelerometer. This is the code itself. It's an example from the Arduino package and is very simple. It is the sweep code. However, I would find in the near future that the code will become much more complicated, and that I would need to make sure that the code is organised and efficient again. This is the testing and final prototype which I made. It looks a bit rudimentary, and it is. It's very basic, but it does work, and in theory, if we had all the equipment for the boat, we would be able to put it out on the water and it would steer to a compass heading, and it would be able to self-right itself by letting out the sails if it got too windy. So this is the rudder action. So when the boat turns off the compass heading by 20 degrees, it turns the rudder to a correct angle in which it will turn back to that compass heading that it's meant to be steering to, and it will continue to do that so long as the boat is steered off the compass heading. So this is all of it working together. It's not a very good example, but it shows that if the boat was tipping over, yes, it would let out the sails, and that if the boat was not steering to the compass heading, it would adjust the rudder to allow it to steer back to that compass heading. So yes, I thank you all very much for listening to this video about my project for 2018 DTC at Dilworth School. Thank you very much.